When we look at the night sky, we're seeing the past, light from distant galaxies traveling billions of years to reach us. This simple fact is the foundation of the Big Bang Theory. Our universe began as an unimaginably hot, dense point about 13.8 billion years ago. The universe has been expanding ever since, like raisins spreading in rising bread. Evidence for this includes the faint afterglow of the Big Bang, the cosmic microwave background, and the abundance of light elements like hydrogen and helium. But calling the Big Bang the beginning leads to a profound paradox. Our intuition expects every event to have a cause, but if the Big Bang created space and time, what does before even mean? It's like asking what's north of the North Pole. The question itself may not make sense. The Big Bang Theory describes what happened after the first instant, but not the moment of origin itself. It's silent on what, if anything, came before. This isn't a failure of science. It's an invitation to ask deeper questions about reality and existence. The story of the universe's birth is where our journey into the unknown truly begins. We know the universe expanded and cooled, forming stars and galaxies, but the true origin remains a mystery. The Big Bang is both a scientific explanation and a doorway to deeper philosophical questions. What set the universe in motion? Science doesn't yet know, but the search continues. And so, we stand at the edge of a cosmic mystery, ready to explore further. Imagine before the universe, before stars, light, or atoms. What was there? Our language assumes a before, but if time began with the Big Bang, the question may be meaningless. Einstein's general relativity tells us space and time are woven together as space-time, a fabric that can stretch and warp. The Big Bang wasn't an explosion in space, but the creation of space and time itself. If time started at the Big Bang, asking what happened before is like asking what's north of the North Pole. Time, as we experience it, is not absolute. It can speed up or slow down depending on motion and gravity. For light, time doesn't pass at all. Our perception is just one viewpoint. The universe doesn't have to follow our intuition. Is the question of before a failure of imagination, or is our understanding incomplete? Perhaps a deeper theory, like quantum gravity, will one day let us peer beyond the Big Bang. Maybe time didn't begin, but transformed. The silence of current theories is a signpost pointing to new physics. We're left with a puzzle. Is there a before, or is that concept itself flawed? The search for answers pushes us to rethink time, space, and the very nature of beginnings. The journey continues, deeper into the unknown. We often imagine nothing as a perfect vacuum, absolute emptiness. But quantum mechanics reveals that even empty space is a bubbling sea of energy. The quantum vacuum is alive with particles popping in and out of existence. This nothing is actually a dynamic field, not a passive void. Quantum fields, like the electron and photon fields, permeate all of space. Even in a vacuum, these fields are full of latent energy and quantum fluctuations. So, the nothing before our universe may have been a quantum vacuum, not true non-existence. This changes our concept of creation. The universe may have emerged from a transition in this quantum sea. The void is a place of potential, governed by the strange rules of quantum mechanics. If the pre-Big Bang state was a quantum vacuum, the universe's birth was a transformation, not creation from nothing. The quantum vacuum is the lowest energy state, but never truly empty. Particles are just vibrations in these fields, even when no matter is present. The origin of the universe could be a shift from one quantum state to another. Nothing is never truly nothing. It's a simmering foundation for everything. The universe's birth may be a natural process, not a magical event. Our understanding of nothing is forever changed by quantum physics. If the universe emerged from a quantum vacuum, how did it become the energetic cosmos we see? One idea: the vacuum was a false vacuum, a metastable state, like a ball balanced on a hilltop. Through quantum tunneling, it could spontaneously decay to a lower energy, true vacuum. This transition would release immense energy, sparking a hot, dense universe. The process is explosive. A bubble of true vacuum forms and expands, filled with energy and particles. This is the heart of cosmic inflation. A universe springing from a quantum event, not from absolute nothingness. The Big Bang becomes a phase transition, like water freezing, but on a cosmic scale. The parent vacuum's origin remains mysterious, but the process is governed by quantum laws. The universe's birth is a natural transformation, not a supernatural creation. This model elegantly links quantum physics to cosmic origins. The mystery shifts, not why something from nothing, but how quantum processes create universes. The story of our universe is a story of transformation, not magic. Time is familiar, yet mysterious. We feel its flow, but physics says its laws are mostly time-symmetric. The arrow of time comes from entropy disorder, always increases. The universe began in a low-entropy, highly ordered state, the Big Bang. As entropy increases, time moves forward. The past is order, the future is disorder. But why did the universe start so ordered? That's a deep mystery. The Big Bang wasn't just the start of space and matter, but of order itself. If time is tied to entropy, asking about before the Big Bang may be meaningless. Stephen Hawking's no-boundary model suggests time blurs near the Big Bang. There's no edge, just a smooth surface. Time as we know it may only make sense within our universe. The beginning of time could be an illusion, a feature of our cosmic history. The arrow of time is a clue, but not a final answer. The true nature of time's origin remains one of science's greatest puzzles. What if the Big Bang wasn't the ultimate beginning? The cyclic universe model suggests endless cycles of expansion and contraction, big bangs followed by big crunches and big bounces. The universe could be eternally breathing in and out, with no true beginning or end. Another idea, the multiverse, where our universe is one bubble in a vast, eternally inflating sea. New universes constantly form, each with its own laws and history. Our Big Bang is just one local event in a cosmic garden of universes. Some bubbles may be lifeless, others wildly different from ours. In an infinite multiverse, every possibility is realized somewhere. Our universe is a single flower in an endless cosmic field. These models challenge the idea of a unique beginning. The story of the cosmos may be far grander than we ever imagined. Our universe's birth could be just one chapter in an infinite saga. Could a universe arise from a quantum fluctuation in the vacuum? Quantum uncertainty allows energy to briefly appear from nothing. Some physicists propose the universe itself could be a quantum fluctuation, a free lunch. The total energy of the universe might be zero. Positive matter energy, balanced by negative gravitational energy. If so, creating a universe from nothing doesn't violate physics. The quantum vacuum is unstable, always jittering with potential. A fluctuation could create a tiny bubble of space-time, which then inflates into a universe. This process could happen repeatedly, spawning countless universes. Our cosmos may be just one of many born from the quantum sea. The nothingness is a universe-generating machine. The laws of physics allow for spontaneous creation on a cosmic scale. Our universe could be a winning ticket in a cosmic lottery. What if the universe has always existed in some form? The eternal cosmos idea sidesteps the need for a creation event. The steady-state theory once proposed an eternal, unchanging universe, but evidence for the Big Bang changed that view. Yet modern theories revive the idea. Quantum gravity models suggest the universe never reaches a singularity but bounces from a previous phase. Our expanding universe could have emerged from a prior contraction. Unlike cyclic models, this might be a single bounce from an infinite past. Time could be eternal, with our era just one chapter. The universe's history may stretch back forever, with no true beginning. Our cosmic story may be a continuation, not a creation. The question of origins remains open, with eternity as a real possibility. Whether the universe began with a bang, cycles endlessly, or is one of many, these ideas reshape our sense of place. The Big Bang gives us a narrative, a beginning, middle, and end. But in an infinite cosmos, our universe is just one moment, one bubble, one possibility. This vastness can feel humbling, even unsettling. Yet, an infinite cosmos means infinite potential for existence and complexity. We are not a fluke, but a natural outcome of cosmic creativity. Science doesn't give final answers, but it lets us ask profound questions. We replace certainty with informed wonder, exploring the edge of understanding. The quest to know our origins is a noble adventure. Whatever the truth, we are privileged to witness and question the universe's story. If you found this information as fascinating and eye-opening as I do, then don't hesitate to smash that subscribe button for even more captivating science content.